Welcome to video 5 of section 2 of our Solutions 1 unit. Today we're going to talk about dilutions, and we use these all the time. If you have those little drink mixes that you squeeze into drops like Mio or Crystal Light or Kool-Aid even makes them, you have a very concentrated solution and you're adding it to more solvent. So when diluting a solution, the only thing we add is more solvent. So, some things change and some things remain the same. So obviously, if we add more solvent, volume changes. If we change the amount of solvent, the molarity also changes. But one thing does not change, and that is the number of moles of solute. It does not change. So that quantity remains the same. We're just adding more solvent, not more moles of solute. So we know that liters times molarity is equal to moles. We talked about that before. So if we look at this in terms of molarity, moles is equal to molarity times liters, which we just rearranged this equation for molarity. We know that that is equal to the moles of solute. So if we just change the liters, we change the molarity, we don't change the moles of solvent, we could get a second volume times our new molarity. So since both of these are equal to the moles of solute, we end up with an equation. And liters was used in this example, but if our liters, our volume unit is the same, we could use any of our volume units. So we end up with the equation M1 V1 is equal to M2 V2. So this is our original molarity and volume, and M2 and V2 is our new volume. The big thing here, and I'm going to put a big star there, volume units must match. So if your answer, if your original volume is in milliliters and it doesn't specify, you can leave your new volume, if that's what you're solving for, in milliliters. So if we look at our example problem, what volume of 18.0 molar H2SO4 is needed to make 1.50 liters of 0.900 molar H2SO4 solution? So here is our original. Here is our new. So we're given a molarity, so that's M1. Here is our new volume, V2, and our new molarity, M2. So in this case, we're solving for V1, our original volume. So this is basically plug the numbers into the equation and solve. So we have 18.0 molar times V1 is equal to 0.900 molar times our V2, which is 1.50 liters. So we have to solve for volume 1, and we end up with 0.0750 liters of H2SO4.